All right, so let's look at this example. This is a problem from 4.1. It's saying we've got this set V where it's the set of all x, y, z such that z equals 2x plus 3y. Okay, so for instance, this point, this would be in that set. This point would be in that. Well, this vector would be in that set, right? Because notice, 2 times the x coordinate 1 plus 3 times the y coordinate equals z. Okay, so that would be in there. 2, 7, 25 would be in there, right? Okay, because 2 times 2 is 4, 3 times 7 is 21, 4 plus 7 is 25. So those 2 points are in there. So the question is this closed under addition? Well, so basically that boils down to this idea. If I have 2 vectors in this set and I add them together, right, just by adding components, is that in V? That's the question. Is that an element of V? Well, look at it. 2 times x is 6. 3 times 8 is 20. Sorry, yeah, 2 times. Let me make sure I get this right. Yeah, 2 times 3 is 6. 3 times 8 is 24. And you're all screaming at me. This should be 30. Again, welcome to live TV. So 2 times 3 is 6. 3 times 8 is 24. 6 and 24 is 30. So look, if this one is in V, this one is in V, and their sum is in V. Now that's just one specific case, okay? If I want to show that this vector space V is closed under addition, I can't do it for a specific case. I have to do it in full generality. So here's how that would look. I would say, okay, suppose I have this x1, y1, z1. Suppose that's my vector, and it is in V. So what that means is let's go this way. Z sub 1 equals 2 times x sub 1 plus 3 times y sub 1. That's what it means for this vector to be in V. Okay, so there it is, a general vector in V. Well, let's take another one. Here's another one. X sub 2, y sub 2, z sub 2 is also in V. So what does that mean? That means z sub 2 is equal to 2x sub 2, whatever they are equal to, whatever numbers they are, 3y sub 2. Okay. So those are 2 general vectors. So if I want to show that this is closed under addition, I need to add these 2 vectors together. And of course we know what that's going to give us. That's going to give us x sub 1 plus x sub 2 as our first vector or component, y sub 1 plus y sub 2 as our second, and z sub 1 plus z sub 2 as our third. Is that, put a question mark, is that an element of V? Well, so the way we test that is we take its z coordinate, which is z1 plus z2, and we ask, does that equal 2 times its x coordinate plus 3 times its y coordinate? Right? That's the question. Does that equality hold? If so, then it is in V. All right, then it's an element of V. Okay, so let's play around with this equation a little bit, and in particular, let's expand this. This right side is just this. Right? But notice, if I just rearrange this, 2x sub 1 plus 3y sub 1 plus 2x sub 2 plus 3y sub 2. Oh, wait a second. 2x sub 1 plus 3y sub 1 equals z sub 1. Why? How do I know that? Because there it is, because that is the rule for our first, the one vector to be in V. And likewise, 2x sub 2 plus 3y sub 2 is z sub 2 because of that. And so look, this does in fact equal z sub 1 plus z sub 2. So we can erase this question mark, and we can say officially, so the sum, I'll just write it like this, the sum of any two vectors in V is also in V. Okay, so that's what it means to be closed under addition. Okay, so now the question is it closed under multiplication? So that means that if you take a vector, x sub 1, x sub y sub 1, z sub 1, and if we multiply it by a constant, right, k, of course that gives us kx sub 1, ky sub 1, kz sub 1. Is this in V? Well, how do you check it? The same way we did before. We say, okay, well, let's take 2 times kx sub 1, 2 times the x coordinate plus 3 times the y coordinate. And hopefully that will equal the z coordinate, but if we have to do a little work first, and the little work that we have to do is just factor out a k. That should be a 2. And look at that. That is, in fact, k z sub 1. Why? Because this is z sub 1. Why? Because this vector is originally in V. And so there we've shown that it's closed under scalar multiplication. And therefore, that represents a subspace, because it's closed. That V, which is described by this rule, the z coordinate equals the x, 2 times the x coordinate plus 3 times the y coordinate, that is a subspace because it's closed under addition and closed under multiplication, scalar multiplication.